Hello, welcome to the Doorgy project's presentation. Our Doorgy door can be controlled with nothing but an app, and it allows the pet scan and leave the house without user interaction. Alright, without further ado, let's introduce our teammate. Our team consists of 4 members. I'm Anthony, and I'm in charge of the I/O operations. And we have Jack, who is in charge of the software and door operations. And we have Liu Qiao, who is in charge of the power and mobile application. And we have Salem, who is in charge of the server and the enclosure of the project. Our project has 6 different requirements, and we split it into 8 different blocks so that everybody have 2 blocks that they are responsible for. And we're going to dive into the different blocks that we've come up with.
For Enclosure, we originally had a design that would allow users to interact with electronics as an as-needed basis for needs such as changing the batteries in the system or trying to fix anything that came up if something were to happen. The original design was meant to be splash resistant and impact resistant to a certain degree without going too overboard with material. Our part was originally supposed to be 3D printed, but we ran into some issues 3D printing it with very little time remaining. So we improvised a impromptu enclosure on our system that would act solely to protect the system and give it a rigid enclosure. For a door unlocking mechanism, we went through a number of different designs for our process. We ended up settling on a design that would pivot on 2 pegs, top and bottom, and then be controlled via an arm extension through the top of the enclosure, or through the bottom of the enclosure. The lock would swing down and would just contain the rhino horn attachment of a servo. The door is designed to withstand 30 pounds of force, however with some material restraints we are unsure of the stability of the door to be able to withstand the 30 pounds of force itself. Web server design, we wanted to create a system that would send and receive JSON files back and forth between an app and the Raspberry Pi. To do this, we needed a web server that we wrote in Node.js, a JavaScript file that we configured to have access to a database. Information about the schedule for locking and unlocking times was sent from the app to the web server, stored in the database, and pulled as needed to be sent down to the Raspberry Pi. The Raspberry Pi would then send a JSON file back to the web server with a list of times that the door actually opened and closed during the time that it was locked and unlocked. All this information was then sent back to the app so that it would have a viewable schedule or viewable history of when certain locked, or when the door was opened, closed, locked, or unlocked. We use the Raspberry Pi as the brains for our system. The Raspberry Pi and part with the PCB would handle all the I/O for our system. It would take in inputs from the IR sensors on the front and back of the system, as well as information for a times table that we received as a JSON file from the web server. The Raspberry Pi would then also send a JSON file back to the web server with information about opening and closing, as well as locking and unlocking times. The Raspberry Pi is composed of 2 main files that work to run the Raspberry Pi. It has one It uses a JavaScript file to manage all the web server connections as well as a majority of the inner I/O or inputs, and then uses a socket connection to a Python script to manage all the servo timings.
For our projects, we have decided to provide the user with the option to either use a wire USB connection or the battery power supply. To do that, we have included a power control unit on our printed circuit board. So as you can see on here, this is our battery power connection. So that it will connect to a battery pack of 4 AA batteries, so it will provide a 6 volt voltage total. and we also have a protection diode to protect the circuit board from any damages in case the batteries were connected in reverse polarity. We also have a protection fuse because the Raspberry Pi GPIO does not come with any protection, so this is just to protect the circuit board from any power surges or anything that might produce excessive current. And here we have a LM317 for our voltage regulator, so it will essentially step down the 6 volt to around 5 volt for the Raspberry Pi. For the Doorgy App, we have a app that's available for both Android and iOS. The Doorgy App will control everything that our Doorgy service will do, including scheduling the opening and closing time, as well as the unlocking and locking mechanism. So that once we open the Doorgy app, we will have to create a user account, which can be a random string that will work. And we do not have hashing function for password, so the password will be saved in plain text, which is not very secure for login information. So it can be once the register button is pressed, it will contact the web server for the information. And once it updated the web server, it put the additional information created at the web server back, and now we have all the other functionality. And as you can see here, we can open the scheduler and view and edit the current schedule, which has nothing in it right now. Go back and create a new schedule for a random date. Oops, there's no 30. And it also have a history for the door operation, but since it's a new account, it doesn't have any history yet. So if we go back to use the account that I have already created, this will be color coded for opening, closing, and as well as locking and unlocking. And on the first page, at the home page, you can see how many updates has been made to the web server. This is how the web server keeps track of which service have the most up-to-date configuration. It has a version control. So if we can click the open and close button, this will update the things on the web server, and you can see the number increment. Doorgy projects will have the IR sensor, which detect motion on either side of the door, and they are strategically placed at a 45-degree angle because the PIR sensor that we use has a 110-degree sensing range. So this will ensure the entire door, including the middle side, is covered, and as well as force triggering from too far away. And we have another block inside, which is a 4 LED indicator. So it indicates the system power on and power off. And we also have a backup kill switch inside in case there's something happening with the Raspberry Pi. It can kill the program instantly. Alright, it is almost the end of our presentation. And let's sum it up. For our project's achievements, our Doorgy projects provide a very simple installation and configuration process with the help of an installer and a configuration utility. The Doorgy projects also allows the complete control of the door with a cross-platform mobile application. The project also employs a modular approach, which all of the hardware can be easily replaced. The Doorgy PCB also comes with many protections, including a diode and a fuse. The Doorgy service was downloaded over 600 times on the npm registry. And for our future development, we'll be adding a camera to help prevent false triggering of the door and to prevent any unwanted entries. And we're going to add back our Bluetooth configuration process to free the user from using the configuration utility, which means the user will no longer have to configure the Raspberry Pi directly. And we are going to add a smart home integration to provide a better and more convenient way to control the door. And lastly, we are going to add an electromagnetic locking mechanism and using gravitation assist closing for power loss protection. So when the Raspberry Pi loses its power, the door will just close by itself with the help of gravity, and the lock will automatically lock it up as the electromagnet is no longer holding the lock back. That is the end of our presentation. If you have any questions or just want to chat, please feel free to join us at GitHub discussion. On behalf of the team, I would like to thank you for spending your time watching and hope that you have a most wonderful day ahead.